Let us begin Chapter 11, Sections 2 and 5. Problem number 1, use the quadratic formula to solve each equation. These equations will have one real number solutions only. So let's remember to write down the quadratic equation in standard form, which is ax squared plus bx plus c is equal to 0. So that's your quadratic equation in standard form. And let's write down our formula for the quadratic equation. So the quadratic formula is negative b plus or minus square root b squared minus 4ac all over 2a. So knowing that, let's look at our problem. Our first step is to bring 14x to the other side. So we have it equals 0. So we have 5x squared minus 14x minus 3 is equal to 0. So let's define our a, our b, and our c. Our a is our 5, negative 14 is our b, and negative 3 is our c. So let us substitute these numbers into our quadratic formula. So we have x is equal to negative b, and b is negative 14. So we have a negative times a negative, which becomes a positive. So we have negative 14 plus or minus square root of b squared, which is negative 14 squared minus 4 times a times c all over 2 times a, which is 5. So now let us solve this. A negative times a negative, like we said, is a positive 14 plus or minus square root. Negative 14 squared is 196. And then we have negative 20 times negative 3 is positive 60 all over 10. So 196 plus 60 is 256. So we have 14 plus or minus square root of 256 over 10. Square root of 256 is 16. So square root of 256 is 16. Therefore, we have 14 plus or minus 16 over 10. So we have 14 plus 16 over 10, which is 30 over 10, which is equal to 3. And then we have 14 minus 16 divided by 10. 14 minus 16 is negative 2 over 10. Negative 2 over 10 can be simplified to negative 1 over 5. And these are our two solutions, 3 and negative 1 over 5. The next problem, we have to write our equation in standard form, which means let us subtract 1 from both sides. So we have 11n squared minus 9n minus 1 equals 0. Let's define our a, our b, and our c. Again, our a is the number in front of the n squared, which is 11. The b is the number in front of the n. And the c is just your constant, which is negative 1. So now let's substitute this into your quadratic formula. You have x is equal to negative b. Again, we have a negative times a negative, which becomes a positive, plus or minus square root of 9 squared minus 4 times a times c all over 2 times a. Now simplifying this, we have x is equal to 9 plus or minus square root negative 9 squared is 81. And then we have negative 44 times negative 1, which becomes positive 44 all over 22. And now the square root of 81 plus 44 is 125. So let's do 9 plus or minus the square root of 81 plus 44 is 125 over 22. Now the square root of 125 can be broken into two square roots, with one of them being a perfect square. So if we have 25 times 5, 25 times 5 is 125, and we know the square root of 125 is 5. So therefore we have 9 plus or minus 5, square root of 5, all over 22. And that is our final answer. Problem, third part of number 1. Here we have a fraction, so the easiest way to solve this quadratic equation is to get rid of these fractions, and to do that we have to multiply each term by our least common denominator, and our least common denominator here is 6. So we multiply each of them by 6. When we do that, we have 6 times 1, which is 6 over 6, becomes 1x squared plus 6x, plus, and here you have 6 times 1, which is 6, divided by 3 is 2. So now we can define our variables. Our a is 1, our b is 6, and our c is 2. So let's plug this into our quadratic formula. X is equal to negative b plus or minus square root of b squared minus 4 times a times c, all divided by 2 times a. So now we can simplify this. We have negative 6 plus or minus square root of 6 squared is 36. You have negative 4 times 2, which is negative 8. 36 minus 8 is equal to 28. So we have here negative 6 plus or minus square root of 28 divided by 2. And again, 28, we can break up 28 into square root of 4 and times square root of 7. We know square root of 4 is equal to 2. So we have negative 6 plus or minus 2 times square root of 7 over 2. And we can still simplify. The 2's can cancel. And 6 divided by 2 becomes a 3. So our final answer would be negative 3 plus or minus square root of 7. And that is our final answer. And the last part of number 1, again, we have a fraction. So to get rid of our fractions, we multiply every term by our least common denominator. And we also have to write our equation in standard form. So let's first get rid of the denominators. So we have 2 times 1 divided by 2, which is y squared, is equal to 2y plus 1. So writing that in standard form, let's bring everything over to the left. So that cancels out. We have y squared minus 2y minus 1 equals 0. And therefore we can determine what our variables are. Our a is 1, our b is negative 2, and our c is negative 1. So plugging this into the quadratic formula, we have negative b, again a negative times a negative becomes a positive, positive 2, plus or minus square root of negative 2 squared minus 4 times a, which is 1, times c, all divided by 2 times a. So we have x is equal to 2 plus or minus negative 2 squared is 4. Negative 4 times 1 is negative 4 times negative 1 is positive 4 over 2. So we have 2 plus or minus square root of 8 over 2. And again, square root of 8 can be broken into square root of 4 times square root of 2. And we know square root of 4 is equal to 2. So we have 2 plus or minus 2 times square root of 2 over 2, and we can cross those 2's. 2 divided by 2 is 1, and this 2 divided by 2 is 1. So our final answer is 1 plus or minus square root of 2. And that is problem number 1. Let's move on to problem number 2. And here we have to graph each quadratic function, and let's label the vertex and the axes of symmetry. So again, let us remember that we're looking at our base graph, which is the graph of y equals x squared. So we can compare each of these graphs to the graph of y equals x squared. And the graph of y equals x squared, we know looks like this: 0, 0. We have negative 1, 1. Here we have 1, so 1, negative 1. When x is equal to 2, we have 4, and negative 2, we have 4. Negative 2, 4. So again, this is our base graph. So looking at the problem that we have, the graph of x squared plus 3 is the graph of y equals x squared. However, it is shifted up by 3 units. So the vertex here is 0, 3. So 1, 2, 3. So it's shifted up by 3 units. And you can just draw your graph like that. So again, it's not at the 0, 0. It's at the 0, 3. It is shifted up by 3 units, and that is the graph of the first problem. The second problem, we have f of x is equal to x minus 6 squared. So the graph of x minus 6 squared is the graph of y equals x squared. However, it is shifted up by 6 units. Again, remember we have the x minus h squared plus k, where our vertex is equal to 6, 0. So our vertex is 6, 0. Let me write down the vertex here for the first one. The vertex here is 0, 3. And the line of symmetry is equal to 0. And the same holds true for the second part. The vertex is 6, 0, and our x is equal to 6. Therefore, x is equal to 6 is the line of symmetry. So let us go to our graph. 6, 0, so let's do these in increments of 2. 2, 4, 6. So 6, 0 is here, and your parabola looks something like that. Now moving on to the next problem in number 2, you have the graph of x plus 3 squared. So again, our formula is x minus h squared plus k. So our vertex is hk, and our h here is negative 3. So we have negative 3, and our k is 3. So our vertex is negative 3, 3. X is equal to negative 3, which that means x equals negative 3 is the line of symmetry. So let us graph our line. We go to x is negative 3, 1, 2, 3, and up 3, 1, 2, 3, and that's our vertex. And our parabola would look something like that. And the last problem, number 2, our vertex is our h and k. Here our vertex is Our h value is negative 4, and our k is negative 6. So our vertex is negative 4, 6. Our x value is negative 4. Therefore, negative 4 is our line of symmetry. And that's where the parabola is cut in half at negative 4. So we can do increments of 2, negative 2, negative 4, negative 6. So negative 4, 2, 4, 6. So negative 4, negative 6 is right there. That is our vertex, and our line of symmetry is at negative 4. So our parabola looks like this. And that concludes Chapter 11, Sections 2 and 5.